two parts. The first part will be updating procedures for IoT. Then I give you a short abbreviated introduction to the dynamic I/O model. Then I make for you a proposal for national and bilateral international IoT. And then we mentioned also, I think it was asked, I think this or yesterday, a short look into a social accounting matrix. These are possibilities for extension in the future. Let's start with updating. I think there came today on the agenda the question to here Mrs. Erden's hand, how do you have updated your tables from 2010 to 11 and to 12? And she has explained to us that she had also a lot of additional empirical data. But if you have not so many empirical data, you must find a mathematical solution. And that I will show you here a little bit. In the Eurostat manual, 2008 on IoT in chapter 14, 3 methods for updating input-output tables are described. They call this 3 methods: univariate, bivariate, and stochastic procedure. All 3 methods try to solve the problem that row and column sums of an input-output table should correspond to given data derived from exogenous projection, and that negative input should be avoided. One exception, in changes of inventories we can also have negative figures. Why? If, for example, your use of goods is higher than your production, let's say we have the year 2011, the production will be 1,500, but in this year they are using the products by 1,600. What should happen? You must take, if possible, 100 from your changes in inventories. And then you have production 1,500 plus reduce your stocks, and then you have again the 1,600. For that reason, it can happen that in the column changes in inventory, changes in stocks, there can come up negative figures. The basic idea of the univariate methods to update input-output tables means you correct the input coefficients. What we have compiled from our basic input-output table, row-wise, by rows, with the so-called diagonal matrix of correction factors. So I think we have now lost already our mathematical professor. He would just ask you, how you are doing that. But it works. We have, I think, a diagonal matrix, and you correct, I think, the data by increasing, by decreasing the coefficients of the year 2010, for example. But it is only a substitute if you have nothing empirical information. I like often the best to combine both. Use as much empirical data as are already available, and then fill only in the remaining steps, because then you have a compromise between a model approach, a mathematical, and the empirical one. In contrast to the univariate methods, bivariate methods are correct rows and columns of one input-output table at the same time. That means you make no correction only of the coefficients by row, but you make at the same time the correction of the input coefficients by column. That means you take into account the delivery structure and the supplying structure. Not only take one of the two. That is what they call bivariate method. And stochastic procedures, the third one, assume that many independent variables may influence changes of input coefficient which do not follow homogeneous row and column multipliers. Then they give in detail an explanation in chapter 14 how it works. I only want to inform you that the possibilities are available. Very famous method works, you have heard it, is the RAS, the RAS method, and sometimes also the PCM method. What are those methods? Stone and his Cambridge group in UK, Great Britain, developed the well-known RAS method, Stone, Bates and Bacharach, already in 1963, which belongs to the bivariate models. Matuszewski, Fitz and Sawyer, these are Canadian economists, proposed the proportional correction method, the PCM method, also just during the time 1964, but this procedure belongs to the univariate model. Both methods begin with new control totals for a later year. So I think that is the minimum what you need. You need for the total output or for the total inputs, you need some new data. I think you need something to which you can make the consistency there later on. So that must be given. Given maybe by God or given by the statistical office or by whom, I do not know, but it can be derived also, but you need the control totals must already be available for a later year. And you alter the coefficients of an old IoT to a mathematical rule so that an updated consistent IO table is obtained. The RRS method uses two sets of multipliers, the effect of substitution and the effect of fabrication to adjust iteratively the coefficient matrix. It's very interesting, updated A plus. And that means always at first you look for a consistency by row. Then you see the difference between the control totals and your new total. There's a difference. Then you say, okay, I make the same approach by column. Then you look here for the difference. So you make an iterative procedure, and step by step the differences between your estimated total and the already given control total will be reduced until they are fully more or less agreed. The proportional correction method pre-multiplies row-wise the matrix of previous input coefficients with a diagonal matrix of only one set of multiplier. Here's the updated A by only a pre-multiplication of R. Here we have the old A, and I think here we have the so-called, that is the substitution effect, and that is the fabrication effect. R is the effect of fabrication that will be working, I think, by column, and the effect of substitution will be working by row, and here it's only effect that will be working by column. Because we don't like to go into detail with these international, very well-known procedure, we developed at the DIW in Berlin an own procedure together with our Mathematical and Statistical Institute at the Free University of Berlin. You see here the DIW Berlin, the German Institute for Economic Research, used another bivariate method to update and to project input-output tables. I have written about this procedure already, a publication in the year 1970. Oh, it's now already about 44 years ago. Oh, I'm so old. Okay. So you see, the objective of this method is called model of double proportionality. It's a little bit in the area of the Rush method, MODOP, model of double proportionality. M for model, M, O, I think for off, D for double, and O again for the O, and P for proportionality, is also to derive missing input-output figures in a process of mathematical iteration, as can be exemplified with the following graph. We have used it very often. I started about 50 years ago. I entered during that time the German Institute for Economic Research Institute in the year 1962. I think you were not born, you were not playing, so it was long, long ago. And what we had, we assumed we have a consistent input-output table for the year T0. And we have for the period T1 only the overall total on the column and in the row. It can be the total of the first quadrant, but it can also be sometimes used for the total table, including also the final use and the primary inputs. But we have only used it for the first part of the input-output table. You see here again what we mentioned, x11 in period 0, x12, first row, column 2, x1j, first row, column j, x1n, first row, column n, also for the period 0. Here is the total of the column, x.10, here we have the total of the row, x1.0. You see the difference, here's a point and the 1, and here's a 1 and the point. This is for the output side, this is for the input side. It is nothing different from our intermediate part of our input-output table from Mongolia, for example. Then we would have here 20 branches or 20 activities. Here we have 20, and here we have the total intermediate outputs, and here we have the total intermediate consumption, and here we have also the total intermediate inputs. For the other here, as a minimum what we need the totals. Here we have x, 1 point for period 0, let's say that will be the year 2000, but for the year 2005 we have only the intermediate output for the branch agriculture, x 1.1, period 1. So we have here all the intermediate outputs for the new period, let's say 2005, and we have also the intermediate inputs for the period. But what is missing? All the intersectoral transactions, our xij1, because here we have xij0, but we have nothing for the period 1. How we can arrive at these figures? MODOP starts from the base period T0 with a complete and consistent matrix of intermediate transactions, where xij0 are the matrix elements and xi.0 and x.j0 are the row and column totals we have seen. For the prediction period T1, which can be an earlier or a later one, all that is required to derive all some matrix elements have already been compiled. To complete the IoT are the intermediate input and output totals xi.1 and x.j1. What I can tell you, when we estimated the first table according to our MODOP procedure, we were able to implement about 66% of all the cells by empirical data. So only the remaining 34% has been estimated according to this procedure. I think that is the best procedure. If you have as much as possible empirical data from your data sources, from surveys, from censuses, and then I think it is also important to try to find out for the most important elements in your tables and empirical data. Because we have made also some analysis with our 56 by 56 matrix. So this is around 3,400 elements or cells. We could see that only 1/3 of this big amount of elements are heavily important for analytical issues. All the other have a very small repercussion on our final results. So you can also identify, that should be done also by the MSO in the future, identify the most important coefficient in your matrix and try to find a lot of data for these important cells. Not for all. There are a lot of data if you look for the original IoT which are negligible. They are not so important. It would be good if for consistency checks we have them all. But for analytical purposes are the main and the important coefficient plays a decision as a deciding role. The missing matrix elements, that means x, I, j, root, are calculated according to our formula. We take the AI and the BG. What are the AI? The AI are the factor of xi.1 divided by xi.0. If we go back, we take this one divide it by this one and get the so-called growth factor for the intermediate output. That we are doing for all sectors. The same we are doing with B. We are dividing x.1 for period 1 by x.1 also for the 20, and we got the so-called growth factor for intermediate inputs, the BG. Then we take the root of these both and we multiply in the first step of approximation the result of this root. You see we include automatically the development by row and the development by column, because we have growth factors for the output side and for the input side. And then we multiply this with the old individual data of this one, and multiplying this with all the growth factor, the root of the both, we get the first approximation. For that reason we express it here with the root. x1, xij1 with the root. This calculation represents only a first approximation, because the totals of the estimated input-output figures generally do not agree with the pretended totals to which they correspond. It means the given data before are not fully compatible with that data which we have now estimated if we sum up row and if we sum up column. Therefore, we took from the RAS method another algorithm of proportionality, which helps us balancing iteratively the matrix step by step. First we come to agreeable rows, then we look for the agreement of the columns, again for the rows, and so on and so on and so on. What is the preference against the rush method? The rush method starts only with coefficients. We have the preference that we start with absolute figures. And we believe starting with the absolute figures for a year and then using the model for extrapolating, we have seen it will be better than only working with coefficients, because in the coefficients you have already a relation between the data and the overall total input. So I think we were very successful with using this model. So I think I have also given, when I think the NSO was for study visit in Berlin, we have given a small example and they also looked for that. So I believe it is an instrument. You can also use the RUS method. I think you can, make the program for both. I can only tell you that also the model of double proportionality will now internationally be also mentioned, and not only RUS and the PCM method. Some words about the dynamic input-output. This morning I told you we have static models and we have also dynamic models. What we have done with all the models so far, these were static models. Static models mean we have no time lag in our computation. We are not movable from one period to the other, they are static. The traditional I/O models described and used so far for static and comparative static policy-oriented analysis do not allow to quantify the impact of new technologies on economic development and on employment. In order to make possible also these applications, two alternatives are possible. You can integrate into our IoT, in our static IoT, variable input coefficients. What we have done very often, we have changed individual cells of the input coefficient matrix by new updated one. That should be done if, for example, you have a change from the old mechanical procedure to the new information technology-oriented procedure. You change the old machine by the new IT computer. Then the coefficient will change heavily, because you can save some labor, but you have more capital. So this can be done by using variable input coefficients in the traditional quantity model. Or you have the time, you have the money to construct a dynamic input-output model. But in such a dynamic input-output model, the determination of investment and its consequences on production capacity of the economy are made endogenous. You are not using the investment column in your second part of your input-output table, you make this endogenous into your input-output model, and you have not only what I mentioned to you, the so-called Keynes multiplier effect, you have also the so-called accelerator effect. Because the accelerator means that you also have impact on the capacity by using the investment. So I think the dynamic approach refers, what is here written down, to the acceleration principle, which assumes that in each period expansion decisions on the increase of sector production possibility are made in accordance with the last development of production in the sector. You see, do we have enough capacity to produce all, to satisfy all our demand by production? If you see, oh no, we have not enough capacity, then we say, okay, we add a new machine. We add a new capacity installation. And that means then automatically you are doing some period of expansion. The same can be done with replacement investment. If you have an old computer, or I think here in the statistical office, they had only sometimes, I think the notebooks, now they are working very modern, I think very updated with tablets. So I think also the tablets are used in the country if they make surveys. So I think it is a big progress from the technical point of view. Because it will be easier, I think you get just the overview. So these will be replacement investments depending on the level of production they expect from the interviewer, a better output. But it should be faster. So I think they are doing it in the investing sector, here it's the NSO, and it's determined separately from expansion. So we have in the dynamic model expansion investment, and we have replacement investment. And that will be reflected in the formula, which looks quite different from that formula we have already seen. The formal structure of the model is substantially equivalent to the dynamic input-output approach of Feydachin and Vasilyev, who in 1986 made an empirical research on future impact of automation on workers in the United States at the Institute for Economic Analysis in New York. They used the following formula for the dynamic quantity model. You see, it's quite different because you see here also, we have here we have different periods. We have the period T, and we have the following period T plus 1. A, that we already know is a matrix of intermediate input coefficients, but now in period T. A T is a matrix of capital coefficients for replacement and modernization, respectively, in period T, RT. BT is a matrix of capital coefficients that had nothing to do with employment. Here the B is again appearing for capacity expansion in period T plus 1, and T and T plus 1 are the time periods. So it is a model which has a different approach and a model that needs a lot of statistical basic information. You need a time series of investment matrices to derive your replacement coefficients and your expansion coefficients. I think in our institute formerly, a colleague has implemented the dynamic input-output model. It was his dissertation, and he needed a lot of time to calculate all the time series of tables, not only IoT tables, but also of the investment matrix to get the different matrices. It is a vast amount of comparable sector data in time series format. So for that reason, it is used not very often. I think my colleague and myself, we were in the United States, and we visited Leontiev, and we took over from him some software for making the model, and that helps enormously my colleague to make his dissertation. I was the second referee for his work, so I think he was very successful, but since that time, never for Germany a dynamic model has been implemented. Because the vast amount of work needed. But perhaps if you are making a small table and take a time series, why not make experiments at universities with some students if they write their dissertation or their master work? So I think it is an idea to jump from the static input-output model, which is generally used, to the dynamic model. Here you see some results. Here is my colleague who is mentioned here, Dietmar. I think it was his work in 1990, and he has used, I think, what he has done for Germany. He has quantified the impact of the introduction of industrial robots on employment in Germany. So we have not the change from blue-collar to white-collar employment as in the United States. We have tried to analyze the introduction of industrial robots. It was also not easy to get information from the machinery industry about the number of robots, but I think he got it. And here are some issues shown. Here are, I think that is one of this economy-wide effects of industrial robots on the employment under different compensation mechanisms. We have assumed there will be substitution, there will be no substitution, there will be some compensation. And you see here, I think the implementation of the robot started in the year 1980, and the final result was the year 1995. So you see here different results according to different scenarios with the implementation. So I think we had both parts, the production of robots and the use of robots, because it's quite different. And that he has taken into account, but I think it was an excellent work, and it was an empirical approach of the dynamic model outside the United States of America. I have another extension or expansion proposal for you. Let's assume we have for land A, that is country A, and input-output table. Unfortunately, I have written this article in German, and I have not the time to translate it, but you see already here, these are the branches 1 to N, the same branches 1 to N. P, V means private consumption, changes in stocks, and these are exports to country B and exports to other countries. You see, the export also we have from country B to country A. This is country A with a full implemented input-output table. That is country B with a full implemented input-output table. What's my idea? My idea is it could be done, I believe, also at the university. Say land A, country A will be Mongolia, and assume land B will be China. China has a lot of input-output tables available. Then make for both countries a comparable classification, so that both tables can be compared. Then try to identify the export from China to Mongolia. You have it in your import statistics, or in the export statistic of China. There might be some discrepancy, because the problem is often if you have the mirror statistics, that not all data are reflected in the data. So we have exports, for example, to Italy, but not exports will be arriving in Italy as imports. Why? Because they are crossing France, and some of the exports will also be kept in France. So I think they will not be shown separately, because I think on the bill there will be finally said, I think the seller will be Germany, and I think the country that will receive will be Italy. But if it crosses the border from Germany to France and then from France to Italy, it can happen that some of the goods will also be used officially in France, and then not all will be arriving in Italy. So I believe if you make mirror statistics, how we call them, you see from one side and the other, like a mirror. You look into the mirror and you say, oh, I am tired this morning, this evening, I think you look better. So the same is as with your import and export statistics. But let's assume that it works. So here we have the imports from B, it will be the export of A. Here are the imports of B from A, and here are the exports from A to B. This one will in this matrix the column, in this matrix the row. This export from B to A will be in this matrix the column, and here in this matrix in Mongolia, the row for imports. What I think could be much better, you make the so-called, from the two different separate input-output tables, the so-called bilateral international IoT for countries A and B. You see here again, also I think the different shadowed tests, the different shadowed cells. That means B has delivered to A has delivered to B, A has delivered another to sector 2. That means that the imports and the exports are divided by the individual commodities or the branches. And you have the chance to build up the so-called bilateral international IoT. So I would recommend that this one should be done. This article where I made the proposal, I think we have done it, I think for one of our regions, from Baden-Württemberg, I think to another country. As you know, we are in Germany a federal system, so we have a lot, I think what you have maybe as MX, we have it officially, I think, we have the whole government, we have the whole Federal Republic of Germany, but I think we have also the different regions and they have their own statistical office, and there are also flows of goods and services from one land, from one country of the whole Germany to the other Länder, to the other land. So I believe that will be an excellent possibility to make some experiments, and I can only recommend. I think it's for the moment not so important to make all the analysis. It's already enough to find the data and to fill in such a table. Here you see also we have the primary inputs for sector 1 in the country A, primary inputs for also for sector 1B, sector 1 and sector 1 to N, but now we brought both together and we have not two separate IO tables for country A and for country B. The last one for today, the SAM. It is not Uncle Sam from the United States, it is an abbreviation for Social Accounting Matrix. Social Accounting Matrix is a matrix presentation of the social account of the nation and has with national accounting a great deal in common. In contrast to our national accounts, which prime interest is to analyze production and use of goods and services, the emphasis of social accounting lies more on the distribution and redistribution of income generated by the production process. I have already also mentioned the private household disaggregation. The SAM can be built on IO data, but requires more detailed information on the household sector and on the generation of primary input. The design of the so-called SAM is not fixed. It depends on the purpose to be served and on the data availability. In the SAM, expenditure and receipts categories are distinguished, as can be seen from the following presentation I have taken from the S&A. As I told you already yesterday, the SAM is now already included in the 2011 Social Accounting Matrix in the chapter. And here you see it is a little bit different because it is more concentrating, instead of what we are looking for the branches, it is concentrating on institutions. Here are our activities from our input-output table. We have a part of redistribution, and we have also different factors. And the factors are a little bit that what I think the professor has asked today here, when he wants to mention the human capital. When I explained to him that we can disaggregate, I think the employment by skilled person, by unskilled person, by high educated person, and so on. Operating surplus also comes here, what we have in the input-output table, and also our depreciation. And here you see that we have that is the main issue in the social accounting matrix, the disaggregation of households. Poorer households, richer households, pension households, rest of the world, enterprises and government. And you see here some data are already hypothetically implemented in the SAM, in the social accounting matrix with SMA. So if you want to know more about the expansion of IoT to the SAM, you can go to the social accounting matrix in the book. I have just heard now the whole book, it's a thick book of, I believe, 768 pages or something like that. It is now translated into Mongolian at the school. Yeah, I think it's a continuation. That is the lower part. Here the redistribution. This is an issue which is not included in the input-output figure. In the input-output we have only where income is generated, what has been done with the income with the final user side, but we have no redistribution. I was asked also today about the problem of the transfers. So you see, if I have the SAM, I can show here some taxes as redistribution. I can have here some other transfers as part of redistribution. This is more or less an aggregated part of our IoT, producing goods, providing service as a government. Here we have the capital. So we have also the same, that the total will agree from the input and from the output. Another design of the SAM according to SNA is here also given. That is the SNA 2008. Also in this one, there is included a table 28.10, and there's also an abbreviated version. And you see also here the goods and services account, production account, primary distribution income account. It looks a little bit like our accounts and our national accounts. What we also have, we have also the accounts in our national account, secondary distribution, use of income, capital account, and also what we have not specifically in our IoT, the financial account. So it is another frame that shows you the SAM in a different format, in a different form. So I believe you have managed all my presentations. I thank you again for your attention. I hope that you learned a little bit what input-output can offer you. It depends on you if you are interested in the addition of the formula to our graph. If you are interested in that, then we have, I think, time to make this also, that we add our formula to the graph, which we have missed so far. If not, I think then we hand over, I think, the microphone to Mrs. Erdene-San, who will end with the latest, I think, part of our text for our workshop. It means some remarks about the future application of IoT for efficient policy making in Mongolia. What are the contributions of the NSO? And we can also make the opposite. She can make the final remark, and then we add it to the graph. Or you believe now you can add it to your own graph. Also possible. It's on you. I think we have the 5 to 10 minutes to edit because we are not in time. What is your preference? Not all together. And do we want to add the formulas? I see no reaction, so I think we'll go ahead.
Yeah, after 사실 때문에 이거 IoT를 사실 대주고 다시나 ер нь бол манай статистикийн газрын зорж байгаа юу гэж боддог. 5 жил тутам нөөцлөлтийн үснээр салбар хоорондын тэнцэлээ байгуулдаг гэсэн. Ер нь зүгээр 5 жил тутамдаа одоо маш дэлгэрэнгүй байдлаар дотоодын нийгэмлэг одоо энэ үнэсэн суурь шинжилгээ тооцоо хийгээд одоо 5 жилийн хооронд хугацаанд одоо арай нэг агрегат хэлбэр юм уу одоо тийм Брамбу байдлаар нөөцлөлтийн үснэгтэй байгуулад яг хэрэв судлаач юудаа төвлөрүүлээд бас салбар хоорондын тэнцлээ байгуулад явъя судлаач цаашдээ олон төлөвлөлтийн шаардлагатай мэдээлэл авъя. Дараагийн нэг зорж байгаа зүйлүүд одоо ингээд жилээр байгуулад ирэхээр бидний одоо байгуулж байгаа зүйлүүд гэвэл дандаа салбар хоорондын тэнцэл нөөц шилдэг хүсэлт маань оны үнээр юм тийм. Тэгэхээр энэ нөөц шилдэг хүсэлтээ зэрэгцүүлэх үнээр боловсруулаад гаргадаг болёо зэрэгцүүлэх үнээр боловсруулна гэдэг маань одоо давхар технологийн аргаар бид үйлдвэрлэл талдаа засрын хэрэглээндээ бүх одоо технологиудаа ашиглаад энэ хэсгийн тооцоог ашиглаад өөрчлөлтийн зурмаар бас зэрэгцүүлэх үнийг гаргаж ирдэг болъё. За ингээд зэрэгцүүлэх үнээр гарч ирэхээр зэрэгцүүлэх үний дотоодын нийт бүтээгдэхүүний тооцооны бас нийгэмлэг байдал оны үнэтэйгээ ижилхэн хангагдаад явдаг болно гэсэн үг. За мөн цаашдаа яг судалгааны ажлыг бас янз янзын хэлбэрээр бас өргөжүүлж болно тийм. Одоо энэ түрүүний сателлит систем гэдэг шиг те янз янзын байдлаар. Гэхдээ яг өнөөдрийн манай статистикийн байгууллага өөрөө юу гэдэг вэ? Гүйцэтгэл суурилж үзүүлэлт гаргадаг болохоос ш бас яг ингээд судалгаа шинжилгээний ажлыг бол бүгдийг хийгээд байдаг зорилготой биш. Гэхдээ бид нар бас мэдээлэл судалгаа шинжилгээ болгох төлөвлөлтөнд шаардлагатай мэдээллийг гаргаж хамтарч ажиллахад бас нэлээд юмнуудыг гаргахад бас боломжтой гэж бодож байна. За дараагийн нэг одоо сая нөгөө юуны сам гэж яриад байна шүү дээ. Сэм одоо сэм social count matrix гэдэг. За энэ маань болохоор яг нөгөө орчуулган дээр яхаар нэгтлэн бодохын матрix гэж ярьсан байна л да. Бид нар бол нэгтлэн бодохын матрix ярьхгүй нийгмийн тооцооны матрix гэж ярьдаг байгаа тийм. Тэгэхээр энэ нийгмийн тооцооны матрицаар бас өргөжүүлж болох юм аа биднэрт одоо мэдээллүүд байгаа бас ойрын хугацаанд бас энэ дээр бас анхаарлаа хандуулаад юугаа салбар хоорондын тэнцлэг хийхээр бас биднэрт бас төлөвлөсөн ажлууд байгаа. Энэ дээр бас ойрын жилээс мэдээлэл бас хэсэг гаргахаар бас зорж байгаа. За дараа нь нэг зүйл юу гэвэл та нар сонссон яасан манайх Улаанбаатар хотын групп гэж байгуулагдсан байгаа. За Улаанбаатар хотын групп гэдэг маань яаж байгуулагдсан гэвэл Австралийн статистиктай хамтраад байгалийн нөөцөд суурилсан эдийн засгийн орнууд те тэрэн дээр одоо байгалийн нөөцтэй холбоотой ямар өөрчлөлт юмнуудыг төсөөлөх болов ямар аргачлал арга зүй бий болгож болох ер нь байгаль орчин маань одоо байгалийн нөөцтэй ашиглалтмал одоо майнингийн үзүүлэлт маань эдийн засагт яаж нөлөөлөд байгаа юм бэ? Байгаль орчинд яаж нөлөөлж байгаа юм бэ? Тэрний одоо тэрний нөлөөлөл нь юу юм бэ? Энэ үзүүлэлтүүдийг яаж тооцдог юм бэ? Ямар ардчил арга зүйгээр гаргаж ирж болох вэ? Ямар проблемуудтай ямар асуудлууд улс орнуудад гараад байгаа юм бэ? Энэ үзүүлэлтийг яаж тооцох вэ гэдэг ардчил арга зүй бий болох зорилготой энэ Улаанбаатар хотын групп гэдэг байгууллагаар явж байгаа. За ингээд энэ Улаанбаатар хотын группийн ажлыг хүрээд бас салбар хоорондын тэнцэлж болон энэ нийгмийн тооцооны матрix аль альны нь болохоор байгалийн нөөц юм уу те эсвэл бүр одоо natural resource юм уу эсвэл одоо яг энэ mine тал дээр те ашигт малтмал эрдэс баялагын бүтээгдэхүүн дээр үндэслэлийг өргөжүүлээд хийж судалгаа шинжилгээний ажлыг хийгээд бас их боломжтой маа. Ер нь уул уурхай маань өөрөө манай эдийн засагт бол голох байр суурьтай байгаа шүү дээ. Уул уурхай салбар. Тэгэхээр энэ үүднээсээ бид нараас энэ тооцоо шинжилгээ судалгаа аргачлал арга зүйг сайжруулах энэ талын ажил дээр бас нэлээдгүй ахис бэрхшээл гаргая гэж бодож байгаа. За дараа нь бидний энэ ойрын одоо үед манай үндэсний статистикийн хороо болохоор үндэсний тооцооны системд 2008-ыг нэвтрүүлнэ гэдэг ярьж байна тийм. Энэ дээр нэвтрүүлэх тал дээр үндэсний тооцооны системийг нэвтрүүлэх тал дээр бол бид нар бас нэлээдгүй ажлууд ахис бэрхшээл гаргасан байна л да. Одоо яг өнөөдрийн өнцгөөс харахад үндэсний тооцооны системийг нэвтрүүлэх тал дээр. За энэ дээр нэг одоо улс орнуудад нэлээд одоо өсрөнгөө хөгжөөд байгаа салбар гэвэл байгаль орчны эдийн засгийн данс. Байгаль орчны эдийн засгийн дансуудыг бас улс орнууд нэлээдгүй байгуулад эхэлсэн байна. За энэ байгаль орчны эдийн засгийн дансыг бас материал урсгалын данснаас нь ахуулаад яаж одоо хэдийн хэмжээний нөөц байгаа энэ нөөцийг хаана яаж хэрэглэсэн гэдгээ бас байгаль орчин талаас холбож үздэг байна. За энэ байгаль орчны дансыг болохоор бас хөдөө аж ахуй, экосистем, natural одоо байгалийн нөөц одоо юу гэдэг бүх талаас нь авч үзэж судалдаг байна. Энэ тал руу бас бид нар ойрын хугацаанд, ойрын ирээдүйд энэ дээр анхаарал хандуулах шаардлагатай болсон байгаа. Илүү бас нэлээдгүй анхаарч ажиллая гэсэн бас төлөвлөгөөтэй байна. За тэгээд нийгмийн тооцооны матрицыг гэсэн тийм иймэрхүү ажлуудыг ер нь манай үндэсний статистикийн хорооны зүгээс цаашид авч хөгжүүлэхэд бас анхаарнаа гэж бас бодож байгаа юмнууд байна. Тэгээд судалгааны хүмүүстэйгээ ерөн судалгааны ажилтнууд бас яам агентлагийн одоо төрүүчийн хүмүүсээс эхнийх нь болохоор түрээсээ түрүү ярьжсэн тийм түрүүний хамтдаа ярьж байгаа явцад бол түрээсээр аваад үзэх юм бол энийг одоо сателлит системтэй холбоот үзүүлэлт хийж болох юм уу? Тэгээд ингээд сабжектаараа яг тухайлсан сэдвээр янз янзын юмар энэ салбар хоорондын тэнцлийг бас өргөжүүлэх боломжтой гэдэг энэ характараас байна. Баярлалаа. За тэгээд эцэст нь би энэ зөв хөгжүүлэх ажил яхаас бас илүүтэйгээр бас профессор Р.Штеглин одоо олон улсын салбар хоорондын тэнцлийн ассоциацийн тэргүүн байсан. Тэгээд мөн одоо Германы статистикийн нийгэмлэгийн тэргүүн байсан энэ хүнтэй бас хамтарч ажилласандаа энэ хугацаанд баг 3-4 жил бид нэлээдгүй олон удаа уулзаж ярилцаж энэ ахис дэвшил гаргахад хамтран ажилласандаа бас профессор Р.Штеглинтэй талархаж хүсэж байна. Тэгээд уртдаа наслаараа олон газар дахиад биднэрт цаашид олон үйл ажиллагаан дээр хамтарч ажил зөвлөгөө өгөх байхаа гэж найдаж байна. Баярлалаа.